My name is Spiros Zantzis, and I'll walk you through the latest developments in ANSA Series 21.1 in the area of modular run management. A few years ago, we announced our intention to systematize the modular management of simulation runs, and we introduced a new unified environment that covers the needs of analysts from the composition of simulation runs up to the management of key results and, of course, for all disciplines. Since then, we've been committed to this target, and we have continuously expanded and improved the infrastructure of the modular environment in several areas in order to improve the user experience and make the environment more appealing, improve your day-to-day work, make the modular environment usable by more teams across disciplines, and of course, facilitate the effective and efficient configuration. Let's start by having a look at the workspace of the modular run management and the changes that have been introduced in this series of ANSA versions in order to improve the user experience and make the environment more appealing. We have completely redesigned the icons that are used for parts and all model containers such as subsystems, simulation models, or simulation runs, and we have introduced in these versions a new family of icons with common characteristics such as the style, the colors, or indicators that are used across the modular environment. These icons not only represent a more modern approach, improving the look and feel of the tools, but they also make it easier for a user to distinguish and understand each container, improving the overall user experience. Moreover, we have updated both the model browser and the DM browser core tools in the modular environment by introducing user toolbars which offer easier and more intuitive access to commonly used functionality. Every action in the toolbar comes with a label and a characteristic icon whose visibility can be configured. These toolbars can be customized with actions or groups of actions from a predefined list that includes user actions. Actions and groups can be changed, reordered, separators may be added, and of course, all the information can be stored per model browser profile, ensuring that every profile that is loaded comes with a toolbar that offers the most appropriate tools. Finally, any actions that are independent of the tabs that are active in the model browser and the DM browser have now been moved out of the toolbars and the tabs and are available on a side menu. Another noteworthy change is the update of the geometry out of subsystems container, which has now been renamed to unassigned and contains all entities that are not associated with any model browser container. In addition, this container now appears in all model browser lists in order to facilitate the distribution of unassigned entities to both base modules and compound containers without the need of the includes list. The next topic is that of the methodology enhancements that have been introduced in order to improve the day-to-day work of users within the modular environment. Saving data in DM is a key process in the modular environment, which involves several steps and goes through certain checkpoints. When working interactively within the modular environment, a wizard-like Save in DM dialog is offered that executes the save workflow in a stepwise manner. For example, trying to save in DM a simulation run, the user needs to take such decisions, for example, regarding the file format, whether to save an ANSA or a solver file, the composition of the main run file, for example, deciding for both the simulation model and the load case whether to copy their content in the run or use them as references. The user will have to deal with integrity check failures, decide the conflict resolution policy, and finally, decide the specific output options. However, going through these options each and every time, of course, is a very tedious and error-prone task, especially taking into account the high impact that some of these settings have in the process down the road. For this reason, the modular environment offers a silent save option. This is a mode which, when active, instructs ANSA to follow a pre-configured save scenario where all the decisions that we described previously are taken automatically based on a configuration sheet without any user interaction. Of course, prior to saving in DM, the modular environment offers a process that each model browser container must follow in order to verify that it's ready to be saved in the data repository and that it meets the requirements of the parent container for the composition of the model. Theoretically, executing the build process of a model browser container on its definition ANSA file, the product of the process is ready to be saved in DM as a solver keyword file. Having such a process in place offers some key advantages. It reduces, for example, the reliance on the individual user to persistently follow set rules. It guarantees the quality of the deliverable product saved in DM. It enables the validation of the integrity of the model assembly, and of course, it facilitates the creation of run iterations. To improve the user experience in the day-to-day work, we have introduced various updates related to the execution of this build process. So let's have a look. From now on, when build is executed on a compound container and an error is identified in the build process of one of its contents, a hyperlink is created in the ANSA info window that redirects the user to the model browser tab where the problematic container is listed and is automatically selected in order to assist the user in the identification of the problem. Moreover, it is now possible to bypass a failed build action through the new Ignore option in the Build Actions context menu. This new option, which is only available on build actions with error status, will switch the status of the build action from error to ignored, allowing the build process to continue. This ignore action, of course, is also recorded in the overall build comment of the model container. As soon as the build status of the container is reset, the ignore status will also be removed and the build action will be normally executed the next time. When the build process is executed, related information is being printed in the ANSA info window. However, after a while, with other information also printed in the ANSA info window during the current session, the build-related information is inevitably lost. To ensure that the relevant information is saved for each and every build action, we have now added a new section in the Build tab in the model browser that captures the output messages of each build action, which are now accessible through this dedicated tab at the bottom right section of the Build tab. While users work in the modular environment to create new simulation run iterations, it is common for the load case to be modified. From now on, changes in a load case that would require the simulation model content to be loaded in order for the build result of the load case to be updated will reset not only the build status of the load case, but they will also trigger the reset of the simulation model build status. For example, when the next iteration of a run that contains a load case header library item is being set up, modifying the settings of the load case header related to the model boundary conditions will trigger the reset of the simulation model build status so that its content will be loaded during build. Similarly, if the load case contained a domain finder with a simulation model defined as connectivity and the settings of the domain finder were modified, the build status of the simulation model would also be reset so that the domain finder can be properly reapplied. Moving on to the next topic in the modular environment methodologies, we have introduced functionality that allows the tracking of changes applied on part and subsystem level, including changes on the geometry, changes in engineering data, or changes of the attributes. This tracking will result in the creation of a change set, an ANSA entity that will contain all actions and parameters applied on the model. When the modified part or subsystem is saved in DM, the database infrastructure allows to keep as metadata and associate a change set with the related DM objects. Looking into the dedicated New Information tab in the model browser labeled Change Set, the user can now easily understand what has changed in the model, track the actions that were applied, and of course identify the part that has changes through an additional image that is stored in subsystem level. In the DM browser, a change set associated with a DM object can be seen in the Lifecycle References tab, together with the change set summary and the characteristic image mentioned before. Switching to the change set tab in the DM browser, the tracked actions can be reviewed in detail. While we're at the DM browser, new functionality to assist the user's day-to-day work is offered through a graphical representation of the lifecycle of a DM object in the form of a pedigree tree. This tree is called the lifecycle graph and is accessed through the respective option in the context menu of the DM object. It displays history relationships, for example, previous or next versions of a given subsystem, and representation derivations, for example, ANSA and solver representations of the same subsystem, allowing for a quick and easy overview of a DM object's lifecycle. A common need when working in the modular environment is to share the target ID ranges or the transformations of subsystems or library items between different simulation model variants. Take, for example, the case of the door subsystems that need to be adapted both in terms of their IDs and their position in order to be used in both the left and the right-hand side of a vehicle for the left-hand drive variant of a model. When the user moves on to build other variants of the same model, the target ID ranges and the transformations of the doors would need to be defined several times. In this ANSA version, we have introduced functionality that allows the reuse of the adapting attributes between model containers. This is feasible either through copy-paste actions or using drag-and-drop operations. Switching to a different subject, it is now possible to mark subsystems and library items as read-only in order to indicate that their files should be treated as black boxes during build and save operation. The indexing process that extracts the definition attributes of a library item or a subsystem the moment it is added in DM has been enhanced in order to also extract information on whether the file contains unsupported keywords or unsupported numbering. Once the base modules are added in DM, their source numbering ranges are indexed together with a marking for the existence of unsupported content. When such base modules are loaded from DM, they're automatically marked as read-only in the respective attribute. Modules that have been marked as read-only will be protected from save both when attempting to save the particular module explicitly and when the saving of this module is triggered automatically from a silent save operation on higher level model containers. In addition, in case the build process runs while the base module is loaded, the definition attributes are retrieved from the DM. Some noteworthy new features related to the methodologies employed daily by the users in the area of the model assembly have also been introduced. Within the modular environment, we have incorporated smart assembly methodologies that offer an easy way for the users to mark interfaces on the model. However, the edit card of such interfaces were too complex in previous ANSA versions, offering more information than the average user would need. Keeping things in line with the redesigned icons and the more modern approach of the workspace tools used in the modular environment, we have redesigned the user interface of the edit card of the most commonly used assembly and load case points, offering an equally easy way to view and edit these interfaces. Moreover, to ease the creation of interface points, we have introduced new creation methods on the center of gravity of selected entities for both nodes or cells, as well as on existing holes of the model with automatic recognition of the holes by ANSA based on a set of settings. Moreover, to allow the user to overcome cases where interface points would fail to be merged automatically during build due to the distance between them being greater than the default merge tolerance, it is now possible to treat with manual paste pairs of undefined and defined assembly or load case points. The new function can be found in the database browser list of interfaces and assists the user in the selection of proper pairs based on their name and their defined status. Finally, we have enhanced the handling of all affected entities when working on an assembly where the interface points of a base module, for example a subsystem or a library item, are used by entities that do not belong to this subsystem. Unloading a module that contains defined assembly or load case points that are used by entities that belong to another container, for example connectors, gaps, or boundary conditions that belong to the assembly's connecting subsystem, undefined interface points will automatically be created by ANSA, in order to facilitate the proper and automatic reattachment of all affected entities when the module is loaded back in the model. Moving on, we have an exciting new feature that is available to facilitate the collaboration between users in the modular environment and promote its use between different teams across different disciplines. In order for several users to be able to contribute their work to the same central data management repository, be it a file-based ANSA DM or SPDRM, they need to be connected to it at all times. To facilitate team collaboration in cases where some remote users cannot be connected to the central DM constantly, or users are not granted write permissions to this central DM, a new function called Send to Other DM has been introduced. With this function, selected content from a central DM can be transferred to a local DM so that users can work on this data extraction offline. Data produced in the local DM as new iterations of previously transferred data can then be pushed back to the central DM. This new function can handle both base modules, subsystems and library items, as well as compound model containers. In case model containers are transferred, all the dependencies are identified and exported along. Thereby, there are no dependencies left between the target and the source DM. For instance, requesting to transfer a simulation run, all of the run contents, the library items, the subsystems, the simulation model and the load case will also be copied from the source DM to the target one. Just before the start of the data transfer, a list will offer a preview of the actions that are about to take place, whereas when the process is complete, another list will pop up, offering an overview and the status of each DM object. The final area where new functionality has been made available is that of the efficient and effective configuration of the modular environment in order to facilitate the daily work of users. From now on, all modular environment settings that relate to the save and load parameters of a model browser container, the composition architecture and file format, as well as the build process, make up a new entity named the modular environment profile. In order to accommodate the need for use of different settings for the users in different teams of an organization, modular environment profiles are identified and stored based on two keys, the discipline and the target solver. This way, for example, you can have two profiles for durability discipline, one using Nastran as the target solver and one using LSDyna with different setting seats. Another profile can be created for NVH with Nastran as the target solver, while different profiles can be created for safety with LSDyna, Pamcras or Radius used as the target solvers respectively. The modular environment profile settings are collected under a new group called Modular Environment in the ANSA settings window. And the modular environment profile can be saved either in the DM or the user's home directory or at a user-defined location through the respective save options. Information about the modular environment profile that will be active for a user on ANSA Startup is stored in the user's home folder every time the ANSA defaults are saved or the user explicitly selects the Set as Startup profile setting. It should be noted, however, that when working in the modular environment connected to a file-based ANSA DM, modular environment profiles are version controlled and every change being made in their settings is automatically reflected as a new version in DM. The moment a model container is saved in DM, the active modular environment profile is also saved in DM and the link is created between the two. This way, the modular environment is at all times aware of the exact settings that were used for the creation of data in DM and is able to reuse the exact same settings automatically on next iteration. In addition, through the modular environment settings, it is possible to differentiate the build process of model containers of the same type. This is done using filtering functionality that allows to assign different build actions to different model browser containers of the same type based on whether their attributes match a given set of filtering criteria. For example, it is possible to filter subsystems based on their subtype and define a specific build process for regular subsystems and a different one for connecting subsystems. To allow the configuration of the data model in use, the DM schema now supports the definition of aliases that can define alternative names for model containers. Using aliases, labels such as subsystem, simulation model, or load case that are widely used in the model browser and in the DM browser can be renamed into something else that is closer to the terminology used in each engineering team. Some examples could be a subsystem being alias to component or module, a simulation model being alias to model or CA model, a load case alias to loading scenario, or for example reports to be alias to key results. The definition of such aliases takes place directly in the data model configuration file. To facilitate the efficient data storage management, the modular environment can be configured to store compressed data files for the DM objects. Saving in DM now supports the use of ANSA.gz files not only for the representation file of the DM objects, but also for the interface representation files, the definition files, ensuring the seamless operation of DM-related functionality, such as the change or the loading of representations, the loading of interface representations, or the next iteration action. Finally, the last topic is that of the use of model interfaces in post-processing. Interface entities used to mark locations for assembly and load case setup in ANSA may also be used for marking locations that will be used for post-processing in Meta, as this enables the effortless, ID-independent identification of model entities of interest. Interface points in Meta could be used for the visualization of interface nodes on the 3D model, the identification of nodes on 2D or 3D, or the creation of a display model, for example. Interface point information is passed by ANSA to Meta with the use of a supplementary file with the extension ALC-aux. This file, which is written in ANSA comments format, can be used in order to pass interface information without the need to keep track of the interfaces in other ways, such as the entities' names or the IDs. To further enhance the usability of these interfaces in the post-processor, we have now enabled the control of the contents of this auxiliary file for simulation runs based on the type of the interface entities and the context, for example, whether they are used for assembly or for load case setup. A usual setup could be seen here, whereby the auxiliary file has been configured in order to contain only those interface entities that are used by the load case. This way, interface entities that are used for assembly are excluded from the post-processor, as they can be too many and may not necessarily be needed for the post-processing. With this, we have reached the end of the presentation.